We've done this three systems of equations problem before. I think we have the answer, and what I'd like to do is solve this same three systems of equations problem using a fourth technique where we multiply by the inverse matrix. It turns out that the reason why this problem takes so long is because we will need the inverse of a 3 by 3 matrix, and that takes a lot of time to produce without a calculator. A calculator can do it somewhat instantly, but today what I'd like to do is go through this process without a calculator. It takes somewhat of a long time. So we're just going to go through this process. 4y plus 5z is equal to 5. We've got x plus 3y plus 3z is equal to 2. And then we've got 2x plus 4y plus 4z is equal to 2. So we got three unknowns requiring three equations. And we've done this problem, as I said earlier, we've done this problem already in three different ways. Each way we got the answers. X is equal to 1. We got y is equal to negative 2. And we got z is equal to 3. Hope you can see that. Seems a little bit darker than usual, but we'll keep going. All right, so the technique that we're going to be working on, it takes this main matrix here where you have 2, 1, 2, and then you've got 4, 3, 4, and then you got 5, 3, 4. All right, so you got that matrix multiplied by this matrix here, which is a 3 by 1 matrix, and that should be equal to 5, 2, 2, which came from here. All right, so now what we're going to do is we're going to multiply by the inverse on both sides. Multiply by the inverse on both sides. So what we'll end up with here, if we multiply by the inverse on both sides, we'll end up with just x, and then we'll end up with multiplying the inverse, which would be a 3 by 3 matrix, to this 3 by 1 matrix. And one of the things that you'd have to know is, by rule, you multiply by the inverse on both sides, you always, on this right side, have to put the inverse function first. So what we'd end up with, multiplying by the inverse on both sides, is we would put the inverse function, multiplying by the inverse of this, would eliminate it. All right, would eliminate it, and you'd end up with x is equal to the inverse of this 3 by 3 matrix. We get 4, 3, 4, 5, 3, 4. So we're multiplying by the inverse of this matrix, and that inverse we're multiplying by this 3 by 1 matrix of 5, 2, 2. All right, and the result of this will end up being your answer. The result of this will end up being your answer, which, as I've said a number of times, we already came out to be 1, 2, 3. All right, so let's start it. And this finding the inverse is a rather lengthy process. So that's why this problem might require the entire hour that we have together. All right, so the way we go about finding the inverse of this 3 by 3 matrix is to start with the main matrix of 2, 4, 5, 1, 3, 3, 2, 4, 4. 2, 4, 4. All right, and we're going to start with an identity matrix of 1, 0, 0, 0, 1, 0, 0, 0, 1. That's the identity matrix there. Just a bunch of ones diagonally going from the top down to the bottom, going leftward there. So the idea, sorry about that. So the idea is to transform this left side to look like this right side. That's what we're going to do through a series of steps where we multiply, subtract, add different rows. We're going to attempt to try to get this left side to look like the identity matrix. And once this left side looks like the identity matrix, the result on the right will end up being your inverse. So the way we're going to do that is we're going to attack this matrix here going from this top corner downward like that. All right, so let's begin the process. So we want this to be a 1 because the identity matrix has a 1 in the upper left-hand corner there. So what we're going to do is we're going to take equation 1, this top equation 1, and subtract equation 2. Why? Because 2 minus 1 is 1, and that's what we want right there in the upper left-hand corner. So we take the top row, subtract the bottom row, we end up with 1, 4 minus 3 is 1, 5 minus 3 is 2, 1 minus 0 is 1, that's negative 1, 0 minus 1 is negative 1, 0 minus 0 is 0. And what we're going to do is we're going to keep the second and third row the same. We're going to adjust a row at a time. All right, so we keep that second row the same of 1, 3, 3, 0, 1, 0, 2, 4, 4, 0, 0, 1. All right, so now we have the 1 that we desired here in our identity matrix. As I said earlier, now we're going for this L shape. We're going in the direction of this L shape. So we attack the 2. Now we're going to attack the 1, which we want to resemble the identity matrix. So we want that to be a 0. Now the way we're going to make this a 0 is to subtract the first and second row again, because 1 minus 1 will give you the 0. So what we're going to do is we're going to take equation 1 minus equation 2 again, and what we end up with, keep the first row the same because we want that 1 to be there. 1, 1, 2, 1, negative 1, 0. I copied down that first row. Now we're going to subtract. 1 minus 1 is 0. 1 minus 3 is negative 2. 2 minus 3 is negative 1. 1 minus 0 is 1. Got to be careful with your arithmetic. Negative 1 minus 1 is a negative 2, and 0 minus 0 is, of course, 0. Let's keep the third row the same. 2, 4, 4, 0, 0, 1. All right. So now, again, the goal is to get this identity matrix of 1, 0, 0. Right now, I've got 1, 0, 2. So I want to attack this 2. The way we're going to attack this 2, because we want it to be 0, is I'm going to take 2 times this top equation, because 2 times 1 is 2, and then I'm going to subtract. I'm going to take twice equation 1. I'm going to subtract equation 3, and the result of that will give me a 0 right here. So that is what I'm going to do. All right, so let's go through this process. Let's go off to the side and make some calculations here. So we've got 2 times equation 1. I'm going to multiply this top row by, when I say equation 1, I really meant the top row, equate the top row here. So 2 times this top row would give us 2. 2 times 1 is 2. 2 times 2 is 4. Multiply this by 2, you get 2, negative 2, and 0. And I'm going to subtract this I'm writing equation 3. I guess maybe to be more accurate, I probably should say row 3. But I think you understand what I'm saying. 2, 4, 4, 0, 0, 1. Now the result of that is going to be our new third row. So let's rewrite the first 2. We get 1, 1, 2, 1, negative 1, 0, 0, negative 2, negative 1, 1. I'm just rewriting the second row, negative 2 and 0. And now our new third row is going to be the result. Oh boy, you can't see what I'm doing. I am so sorry. The result, our new third row is going to be the result of the subtraction of these 2 rows here. So we take 2 minus 2. That's going to force us to put 0 here. 0 here. And then we're going to take 2 minus 4. That's negative 2. All right, so we're going to take 4 minus 4. That's 0. 4 minus 4, that's 0. 2 minus 0, that's 2. Negative 2 minus 0, that's negative 2. And 1 minus 0, that's negative 1. All right, so we got to be very, very careful with our arithmetic. Very easy to make silly arithmetic mistakes. And with math, you make one minor mistake. You can know what you're doing, but you make one minor mistake, and that really, really messes up everything you've been working on. All right, so now look what we've got. We've got 1, 0, 0, and we're getting closer and closer to this identity matrix, 1, 0, 0. And I told you we're going to go in this L shape here. So the next number we're going to attack is this right here. We want that to be 0. So we got 1, 0, 0. We want that to be a 0. So the way we can do that is just to subtract the second and third rows. We subtract the second and third rows, you get the negative 2 minus negative 2, which is 0. So let's go through that process. Let's go ahead and do that. All right, so we're going to take equation or row 2, subtract equation or row 3. All right, so let's keep the top row the same. We got 1, 1, 2, 1, negative 1, 0. Let's keep the second row the same. 0, negative 2, negative 1, 1, negative 2, and 0. And now let's subtract equation 2, equation 3. Row 2 and row 3. So we end up with 0 minus 0 is 0. Negative 2 minus negative 2, that's 0. Negative 1 minus 0, that's negative 1. 1 minus 2, that's negative 1. Negative 2 minus, that's 0. And 0 minus a negative 1 is 1. All right, so we're getting closer and closer to getting this identity matrix on the left. All right, so we want this to be a 1. So we're going in this L shape. We want that to be a 1. All right, so what we're going to do is just divide by a negative for this bottom row to make that a 1. All right, so let's just divide equation 3 by a negative. And if we do that, can you see that? Yeah, okay. So if you do that, what you end up with is the top row, 1, 1, 2, 1, negative 1, 0, 0, negative 2, negative 1, 1, negative 2, 0. And let's just divide this bottom row by negative 1. Divide this bottom row by negative 1. So 0 divided by negative 1 is 0. Negative 1 divided by negative 1 gives us the 1 that we wanted there. And you divide this by negative 1, you get 1. This becomes 0, and this becomes negative 1. All right. So I want everyone to be clear. That this is not the most efficient technique to use. For anyone who's watching, maybe you just tuned in. If you just tuned in, we've already solved this 3 by 3 matrix. We've already solved this 3 by 3 matrix using 4 different techniques. We've already used 3 different techniques. We've already used 3 different techniques, and we're just solving this probably using the most inefficient technique. It's called multiplying by the inverse. So what I'm doing is I'm going through this process. Again, this is not the first technique that you would use. I'm just trying to use what I call mastery level understanding of a subject, solving the same solving a problem using a variety of different techniques. All right, so let's keep going. All right, so we're going to attack this negative 1 here. We're going to attack this negative 1 here. And the way we're going to do that is we want this to be a 0. We want this to be a 0. If you look at the identity matrix again, you look at the identity, you got the 1 here, you got the 0 above that. All right, so we got the 1 here, you got the 0 above that. So here we got the 1, and we want that to be 0. So the way we're going to get it to be 0 is to add row 2 to row 3. All right, so let's take row 2. Let's add it to row 3, or equation 2, or add it to equation 3. All right, equation 2, equation 3. If you add them, so let's keep the first row the same. We get 1, 1, 2, 1, negative 1, 0. And we have 0, negative 2. I'm just rewriting that. I'm just rewriting this. 0, negative 2, negative 1, 1, negative 2, and 0. Rewrote that. And now I'm going to add these two rows here. That's going to be my new third row. So we add, we get 0, negative 2. Oh, I'm sorry. I did the wrong thing. Forgive me. What I was trying to do, sorry about that. What I was trying to do is adjust this. I want this to be a 0. Forgive me. So the result of adding row 2 and row 3 will actually be replacing the second row and not this row. I want this third row to stay the same because I've got the 0, 0, 1 here, which is the same as the identity matrix. So forgive me. I made an error there. So what I'm going to do is erase this second row. Sorry about that. Erase this second row and replace it with the sum of 2 and 3. So if you add row 2 to row 3 here, we'd get 0. All right. We get 0, negative 2, negative 1 plus 1, negative 1 plus 1, that's 0. 1 plus 1 here, 1 plus 1 here, that's 2. Negative 2 plus 0, that's negative 2. And 0 plus negative 1, that's negative 1. All right? All right. So now what we want to do is put down the old third row that we have because that was the identity matrix, that part of the identity matrix we want. So we got 0, 0, 1, 1, 0, negative 1. All right, so I hope we didn't confuse anyone there. I had kept this second row the same when really we wanted to attack the number that was here, which was a negative 1, to make it 0. All right, so I replaced it with the second row. That's what we wanted this second row replaced, and I kept the third row the same. I'm hoping that no one is confused by what I did there. All right, so now what we want to do is we want to attack this number here. We want this to be a 1. Because as I told you before, this identity matrix has 1s along the diagonal there. All right, so we want that to be the 1. That to be a 1. And the way we're going to get it to be a 1 is divide this entire row by negative 2. We divide by negative 2. Negative 2 divided by negative 2 is a 1. All right, so we're going to divide equation 2. Divide equation 2. And I'm hoping that, let me just say row 2. Divide row 2 by negative 1. I'm just using the word row instead of equation. That shouldn't confuse you. All right, so I'm taking this second row, dividing by negative 1, keeping the first and third row the same. So we get 1, 1, 2, 1, negative 1, 0. Now I'm going to divide that second row by negative 2. This goes unchanged. You get 0. This negative 2 becomes a 1. This 0 goes unchanged. Divide by negative 2 here, you get negative 1. Divide by negative 2 here, you get 1. And divide by negative 2 there, you get half. And what we're going to do is we're going to keep this third row the same because this is what we want. We want that 0, 0, 1 there. That's part of the identity matrix. All right, so we're getting closer and closer. We're getting closer and closer here. We got a 1, 0, 0, 1, 1. You got ones along that diagonal, so we're getting closer and closer to getting this identity matrix. What we want now is we want this to be a 0. All right, we want that to be a 0. So the way we can get it to be 0 is we can take twice this equation 3. That'll become a 2, and then we subtract it from this top equation, and then we'd get 0. All right, so we're going to take equation 3. We're going to take equation 3 and subtract. Take 2 times equation 3 and subtract equation 1. All right, so we're going to take twice equation 3 and subtract equation 1. Again, the reason why we're doing that is we take twice this equation. We're trying to get a 0 here. So, but if we take twice equation 3, this will become a 2. And if this is a 2 and then we subtract it from equation 1, it'll give us a 0 that we want there. All right, so let's go off to the side and make a little calculation. 2 times that bottom equation. All right, so 2 times this bottom equation would give you 2 times 0 is 0. 2 times this 0, that's 0. 2 times 1 is 2. 2 times this 1 is 2. 2 times 0, that's 0. 2 times negative 1, that's a negative 2. All right, so we multiplied equation 3 by 2. Now what we're going to do is we're going to subtract equation 1. So equation 1 is 1, 1, 2, 1, negative 1, 0. All right, so if we subtract, in fact, what I think I'll do is just to simplify this process, if I subtract here, I'll get a negative, and I don't want a negative. So what I'm going to do is I'm going to take this bottom equation 1, and I'm going to subtract twice equation 2. So I'm going to subtract this bottom minus the top. That way I get 1, and then I get a 1 here. I don't want a negative here. I don't want to get a negative. The identity matrix has a 1 in the upper left-hand corner, and if I subtract the way I had this written before, I would get a negative 1, and I'm trying to avoid that. Some might say, well, just go ahead and subtract. You get a negative 1, and then just divide it, but that would require another step, and I'm trying to avoid that. All right, so I'm going to take the bottom minus the top. I'm hoping that that's not confusing what I'm saying. All right, so if I take the bottom minus the top, I get 1. And bottom minus the top, I get 1 there. 2 minus 2, I get the 0, which was the purpose of this step. 1 minus 2, that's a negative 1. Negative 1 minus 0, that's a negative 1. And 0 minus a negative 2, that's just 2. It's just 2. All right? So now let's keep the second row the same. We get 0, 1, 0, negative 1, 1, and half. Let's move this a little to the side here. Uh-oh, I am so sorry. Got to concentrate a little bit better. So that should be a 1. Only thing I've done is I rewrote this second row right here, and now I'm going to rewrite the third row. 0, 0, 1, 1, 0, negative 1. All right, so we got one more. We've got one more number to attack, and then we'll have this identity matrix on the left. You probably have observed by the amount of time it's taken us just to come up with this inverse how inefficient this method is. As I said earlier, we've done this same problem in much more efficient, using much more efficient techniques. and this is the last time we're doing a problem. We're using the most inefficient technique. Takes the longest amount of time. There's an incredible opportunity to make a mistake. You probably are observing that I'm really talking somewhat slowly, and I'm just trying to make sure that we don't make any mistakes, because again, if we make a minor mistake, it'll mess up your entire problem. All right. So let's keep going. We've got to attack this 1 here, and hopefully you see that we want to make this 0, and the way we can make this 0 is just subtract row 1 and row 2. Let's take equation 1, subtract equation 2, and if we do that, we get 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 0, that's 0. Negative 1 minus negative 1, that's 0. Negative 1 minus 1 is a negative 2. And 2 minus half is 3 halves. 4 halves minus 1 half is 3 halves. Now, let's keep the second row the same. 0, 1, 0, negative 1, 1 half. 0, 0, 1, 1, 0, negative 1. So we started out, all right, so we started out, notice how we've got our identity matrix on the left here, which is what we wanted. So we went from an identity matrix to a different matrix on the right side. All right. All right. We went from the identity matrix to this matrix here on the right side. And what I want you to see is the original problem, we started out with the identity matrix on the right side. Now the identity matrix is on the left side. All right, so here the identity matrix is on the right, and we had our main matrix here on the left. So the point I'm trying to make is our goal, our intent was to get this identity matrix on the right, and the result on this right side becomes your inverse matrix, which is this matrix which we want right here. This means the inverse of the matrix. So we just found it. We just found the inverse, and it's right there. That is our inverse matrix.